everyone, I hope you all are doing well. So this side Priya Bhatia, and in this particular video we will talk about another amazing concept with respect to machine learning, and this is about a decision tree. Please mark my words that this is one of the very important concept in machine learning, because this concept is the fundamental for the next upcoming algorithms as well in the machine learning playlist. But before watching this video, I am pre-assuming that you already have watched my complete playlist, whatever videos I have uploaded so far. Now, in this particular video, to understand the decision tree, as the name itself suggests, that you should have a basic idea about the tree-based data structure, which we usually have in data structure algorithms, right? That's where the DSA plays an important role. Now, if there is someone who is not already aware about the basic fundamental concepts of trees, I would suggest that please go and watch my playlist of DSA using Python. They will be able to understand this concept pretty well. Okay. So now let's get started and we'll try to understand this another amazing concept of machine learning. In this video specifically, the purpose is to talk about the mathematical intuition, and in the upcoming videos we will try to see the implementations for the same. You all know that fundamental understanding is firstly the primarily step in order to understand any algorithm. So with this, let's get started. So first of all, let's try to understand the concept of Gini impurity in a decision tree. Okay. So here, whenever we are trying to have some data set, for example, I have taken here some random data. I hope you can see the image very clearly. In this data set, we will be having three important features. One is class, one is gender, and the last is the target column that we have, which is that whether a person will stay in the hostel or not, depending upon his or her class or gender, right? Now, what usually happens is, whenever we are trying to create a decision tree, what is the meaning of that? For example, if suppose I'll say that, I want to see that what is the survival rate of the person. So maybe the survival rate will depend on that whether a person is male or female. So I want to calculate or see what is the survival rate of a person. Now, in order to check the survival rate, we know that we will be having a feature known as gender, which is important parameter. Now, in gender, on the basis of that, we have two gender, maybe one is male, one is female. Now, depending upon the age duration, you can say that, male is having a, if the age is, suppose you are saying that now age is another feature that we have after gender, which will come. And on the basis of age, if a person is having an age of maybe more than 70, then there is a very less chance of survival, or a person will not survive, let's assume. And if the case is vice versa, then a person will stay. So if the age is, less than 70, in that case, a person will stay. If the age is bigger than 70, the person will not stay. Maybe in female, that portion is bit higher. Let's assume that, if a lady's or a female age is bigger than 75, then she will not survive. Otherwise, if the age is less than 75, maybe that particular women will survive. So what is the meaning of a decision tree? The meaning of a decision tree is that at each and every time we will be having a features, and the final outcome is either we are trying to solve any classification problem or we are trying to solve any regression problem. I hope that you already have watched my playlist of machine learning, where you already have seen that what is the meaning of classification problem, what is the meaning of regression problem. So yes, whenever I'm talking about decision tree, it is suitable for both, for the classification as well as the regression task. So when I'm saying classification task, on the basis of this complete, decisions, on the basis of complete this tree, we are making at the end of the day the decision. This is something that we call as leaf node in a tree. I hope those who are already aware about tree-based data structure, they must know. And the tree contains a starting node as the root node. So every particular node that we have in this decision tree is a feature, and finally at the leaf node we will be able to get the outcome as either yes or no. That's something that we called as a decision tree, right? So we are able to make a decision here. Now what I tell you that here, how much a particular node is impure, how much a particular node is impure. For example, in this case we will be having two features. Feature f1 is class, feature f2 is gender. How will I get to know that, class should be the root node, or how will I get to know that gender will be the root node? In a way, how will I do the creation of this decision tree? And that's where the concept of Gini index as well as the entropy came into picture. So there are two important concepts that we have to talk about. Today in this session, we will talk about Gini index, but there are two parameters which I am talking about here. One is something that we are calling it as Gini index. Second is something that we are calling it as entropy. So let's try to split this video into two parts. In this first video of decision tree, we will try to focus on this Gini index part. And in the next video, we will try to focus on the entropy part. Now, when I'm talking about Gini index, what I'm saying is it is a measure of impurity. Now, whenever I'm trying to create a decision tree, I have to decide what should be the root node. I have to decide what should be the internal node. What is the meaning of internal node? The node between the root node and the leaf node. All these in between nodes are the, whatever features we are taking it as a internal node. All these are the internal nodes. All these are the internal nodes. So I have to decide, right? Suppose here I just have only two features. So which feature is something which I can take it as a root node? For that, I have to calculate the Gini index. Now, whichsoever is having a value of minimum Gini index, that will become my root node. That will become my root node. And that's how the complete structure of tree will be formed. So what I'll do is I'll try to upload that image in this new particular page. And now here, if you will see, we will try to do the calculation of how we can compute the Gini index first. So here, if you will see, we will be having a class. So we will try to see that we will be having a class, and we will try to sort the class, which is 8, 9, 10 and 11. Now on the basis of this class, whether a person will stay in hostel or a person will not stay in hostel, right? So in this case, if I'll say how many of them are staying in hostel belonging to class 8, how many of them are staying in hostel and how many of them are not staying in hostel? So you will say that this is the first record and this is the second record. So there are two records which are yes, there is only one record which is no. Similarly for class 9, yes is 1, 2 and no is 1. So here yes is again 2 and no is again 1. Similarly for the class 10, here if you will observe, for the class 10, here if you will observe, there are 2 no's and 1 yes. There are 2 no's and 1 yes. Similarly, if you will observe for class 11, if you will observe class 11, 1 yes, 1 no. It means 3 yes are there as far as I can see. There are 3 yes and 1 no. 1 no. So in a way, if you will observe, with respect to 10, we have 4 records, right? I think I have mentioned it somewhere rogue. 1, 2, and then 3 no and 1 yes. So let me just rewrite it again. So here we will be having 3 no's and 1 yes. 3 no's and 1 yes. So now what we have to do here? We have to find out what is the probability of yes and what is the probability of no. So what we can do? To calculate the Gini value, what we can do, let's try to understand. Please be involved in this session and try to watch this video till the very end. Then only you will be able to appreciate what concept we are studying today. Okay. So it requires a bit of patience. So total number of records, if you will observe, in the 8, I have 3 records. In the 9, I have 3 records. In the 10, I have 4 records. In the 11, I have 4 records. So in total, if you will observe, I will be having 4 plus 4, 8 plus 3, 8 plus 6, I would say 14. So in a way, I am saying that I will be having 14 number of records, right? Now, in this case, if you will observe, if I'll ask you, what is the Gini index? What is the Gini index for class equals to 8? For class equals to 8. Because here we are trying to do the calculation for the classes part. Now, the formula to calculate the Gini index is 1 minus summation of P of I whole square, where I is equals to 1 to n, where n indicates how many number of classes do we have. How many number of classes do we have, right? So this is the way to compute the value of the Gini index. This is the way to compute the value of the Gini index. Is it clear? Is it clear? Right? So now here if you will observe, when the class is equals to 8, what is the probability of yes? What is the probability of yes when the class is equals to 8? Can I say it will be 2 by 3? Can I say it will be 2 by 3? Because what is the meaning of probability? How many number of records are yes out of total records? So it will be 2 by 3, right? What is the probability of no? What is the probability of no in class 8? It will be 1 by 3. It will be 1 by 3. So here if you will observe, the Gini index will be equals to 1 minus 2 by 3 whole square plus 1 by 3 whole square. So here if you will observe, what we will be able to get is 1 minus 4 by 9 plus 1 by 9. So here what we will be able to get an answer is 1 minus 5 by 9, which is equals to 4 by 9. So this is the formula to calculate the Gini index for the class value equals to 8, right? Moving ahead, let's try to calculate what is the Gini index when I am talking about the class as equals to 9. Class equals to 9. So here if you will observe, again the probability of yes in class 9 is 2 by 3 and the probability of no is again 1 by 3. So what I can do, I can say 1 minus 2 by 3 is the probability of yes plus 1 by 3 is the probability of no. So here if you will observe, the answer will be equals to 4 by 9. Similarly, if we will try to calculate what is the Gini index value for the class equals to 10, what we will be able to get an answer. What is the Gini index for the class equals to 10? Again, what will be the answer? So here again what we will be able to compute is, we will be able to compute 1 minus, what is the value for the yes? 1 by 4. What is the value for the no? It will be 3 by 4. So it will be minus 1 by 4 square plus 3 by 4 square. So here what we will be able to get is 1 minus 1 by 16 plus 9 by 16. So it will be nothing but is equals to 16 minus 10. I believe it will be equals to 6 by 16, which is equals to 3 by 8. 3 by 8. Similarly, the last important thing that we have to evaluate is what is the Gini index for the class value equals to, I believe it would be equals to 11, right? It would be equals to 11. So here if you will observe, when the class is equals to 11, again it will be 1 minus, what is the probability of yes in the class 11? It will be 3 by 4 and no is 1 by 4, right? I hope everyone knows how we can evaluate probability. There is no need to talk about more about that part. 1 plus 1 by 4 whole square. So here I think the answer will remain same. It will be nothing but is equals to 3 by 8, right? It will be nothing but is equals to 3 by 8. So here if you will observe, we will be easily able to calculate the Gini value for class 8, class 9, class 10 and class 11, right? Now what we really want to calculate is, we want to calculate what is the Gini index value, for a complete class, for a complete class feature. How we can evaluate that? Just have to see how many number of records are there. What is the probability of the number of records of 8? It will be 3 out of 14 because in total we will be having 14 number of records. So what you have to do is, you have to find out the combinational Gini index, which is 3 by 14 multiplied with what is the Gini index for the class 8? It will be equals to 4 by 9. Similarly, if I'll ask you how many number of records we have for class 9, it will be again I believe 3 by 14 into, the answer will remain same, 4 by 9. Then again, what is the Gini index value for class 10? I think it will be 4 by 14, right? Into, what is the value? It will be 3 by 8. Right? Plus, again, what is the probability for class 11? It will be again 4 by 14 into 3 by 8. So here if you will observe, we are getting 3344. That's what we have mentioned. 3344. So 3 by 14, 4 by 3 by 14, 4 by 14, 4 by 14. Now what we really want is, we really want to calculate what is the value we will be able to get here, right? So if you will solve this value, you will be able to get the answer as 0.404. 0.404. You can try to, use the calculator here to do the calculation. So this is how basically the computation of complete Gini index feature will be done. So what we have done is, first of all, we will try to compute it, step by step with respect to each and every class that we have. And afterwards, we will try to compute it for the complete feature that we have. That's how the complete calculation will be done. Now, moving ahead, this is for the class, which is 8, 9, 10, 11. Similarly, we have to compute for the Gini index for the gender. Now here, if you will observe with respect to gender, how the columns will be made with respect to gender. Now with respect to gender feature, if you will observe, in case of a gender feature, we will be having two features. Either a gender will be male or the gender will be female. Now here, if you will observe, we will be having two columns. Stay in hostel. So what is the value of yes and what is the value of no? What is the value of yes and what is the value of no? In both of the cases. So if a person is male, and the value is yes, how many number of records are there? If a person is male and the value is yes, 1, 2, 3, 4 and 5. It means that in total we will be having 5 number of records. Right? How many number of records are there which are no? Male and no. So here, if you will observe, male and no, 1, 2, 3, right? So in total, I believe there are 3 number of records that we have with respect to male and no. Similarly, we will try to evaluate female and yes. So similar task I am doing here, nothing much difference here I am doing. So female and yes, 1, 2 and then 3, right? This one is third. So in a way, we will be having in total 3 number of records with respect to female and yes. So here, if you will observe, we will be having 3 records here, and I believe there are 3 no will be there. Now we will be having total number of records here, if you will observe, 8 here and 6 here. So that's why total number of records will become 14, which is so true. Now again, what we will try to compute, what is the Gini index? For the male. So it will be equals to 1 minus, what is the probability of yes? It will be 5 by 8 whole square. Plus, what is the probability of no? It will be 3 by 8 whole square. So it will be 1 minus, you can evaluate 25 by 64 plus 9 by 64. Similarly, what we can do, we can try to compute what is the value of a Gini value, or a Gini index with respect to the female part. And here also we will be able to get an answer which is equals to 1 minus, what is the value of male? It will be 3 by 6. What is the value of female? Again 3 by 6. So 3 by 6 square, 3 by 6 square. Now you can evaluate this part as well. So what will happen is, you will be able to get the answer here as 0.5 and here as 0.468. I already have evaluated, so I am just writing down the answer. You can try to evaluate at your home, okay? Now, here if you will observe, if I'll ask you, what is the Gini index for the complete feature name gender? So you will answer to me, it will be nothing but is equals to, how many in total number of records of male are there? It will be 8 out of 14. So it will be 8 out of 14 and the value is 0.468. Similarly, here it will be 6 by 14 and the value is 0.5. That's it. Now what we can do, we can just try to get the final result, which is nothing but is equals to 0.482 approximately. Right? Now here if you will observe, the Gini index of class is 0.404 and the Gini index of gender is 0.482. So here if I'll try to compare these two values, the class and the gender, which one is having a lower Gini index? Obviously the class is having a lower Gini index, and that's the major reason I would say that, class will become the root node. Class will become the root node. So why is that so? Because it is having a low Gini index as compared to gender feature. That's what we have seen. Now what will happen? Obviously the next part will come as in the class we will be having the class as 8, right? There will be 4 subclasses: 8, 9, 10 and 11. And again what you will do? You will try to create again a subtables which contains gender only, because now for every class we will be having the subtables. So we will be having a column by the name of a gender, right? And here, how many number of subclasses do we have belonging to class 8? So here if you will observe, with respect to 8, how many number of records do we have? So here if you will observe, the number of records will be equals to 1, 2, 3. There are 3 records. And the good thing is all are female. And the answer is yes and no. Right? Yes, no, yes. So here we will be able to get the answer as 3 records, 8, 8, 8. All the gender is female, right? And the value is yes, no and yes. Similarly, you will try to structure it down. What is the value of 9? What is the value of 10? 11. Where the important feature is yes, gender and the target value which we have, whether the person will stay in hostel or not. So this is how further again you will try to compute and will try to draw the attention that, okay, what will be the answer, the how you will create. So here what will happen? With respect to 8, we will be having only one gender column, which is female. And inside this female, there is a high probability of yes, which is 2 by 3. And there is a low probability of 1 by 3, which is no. This is how complete structure will be formed. Where at the very end of the leaf node, you will be having either yes or no. You will be having either yes or no. And this is how the same thing you will try to do for the 9, for the 10, for the 11. Now, if you will be having multiple features also, maybe more than 2 features, maybe 7 features, 8 features, you will do the same task to compute again and again for every feature what is the value of a Gini. And whichever feature is having a lower Gini value, that will become your next important feature in the decision tree. Next important node in the decision tree. Now here if you will observe, if someone will ask you, what is the complexity required to get the final answer, either it is yes or no. At the testing time, whenever you are trying to enter the new data and you want to test that what should be the outcome. For example, in future, if I am saying that I will be having a value like, again the class belong to 8 and the value is female, what will be the answer? What will be the answer? So what you will say? You will go to the decision node, you will say it is 8, I'll go to the female, and I said that, okay, the probability of yes is no. Yes is very high, so the answer will be yes. This is how the thing will work, right? So in a way, whenever I'm talking about a complexity part, it's very important. It's very important to understand for every algorithm what is the complexity. Now, whenever you are trying to test the data, right? You have to traverse a decision tree from root to a leaf node. Can I say? Because at the leaf node itself, you will be able to get the final answer. At the leaf node itself, you will be able to get the final answer. So in a way, can I say it will be nothing but is equals to big O of what is the depth of a tree that you have, or what is the height of a tree that you have, right? Now here, what is the complete height of a tree? This is the complete depth, right? This is the complete depth, or we can say the height of a tree, right? And now, what is the space complexity of this? Means how much extra space your code is taking to execute this program. So obviously, it will be nothing but big O of the number of nodes that you have, because you're trying to store it in a data structure. So here, this is something that you can say is the space complexity. This is something that you can say is the space complexity, right? This is something that you can say is the time complexity. Time complexity, right? I hope this is pretty much clear to everyone. And if someone will now ask you what is the time and the space complexity of, testing your data set in the decision tree, you will be easily able to answer that point. Now, moving ahead, if suppose someone will ask you, what is the minimum and the maximum value of Gini index? Or I would say in other words, what is the range? What is the range of Gini index? What is the range of a Gini index? So in this case, if you will observe, what is a pure sample? What is a pure sample? The pure sample is where at the very end, you will be having either completely all the values as yes or all the values as no. That's where you will say that the sample is very pure. Means that's where the value of Gini index will be 0. How? For example, you will be having maybe yes as the number of records and the no as the number of records. And you are saying that, maybe all the samples, what can I say? That if the gender is female, I am saying that the person will stay in hostel. And I am saying for the yes, the value is maybe 3, and for no, the value is 0. So in this case, if I'll ask you that, what is the probability? So you will say it will be nothing but 1 minus summation of probability of yes. So it will be nothing but 3 by 3 whole square plus 0, right? Plus 0. Can I say, everyone? Can I say? Because all the samples are belonging to yes only. No sample belong to no. It means there are only 3 students, and if the gender is female, all are going towards the staying in the hostel process. So here if you will observe, your value of Gini will become 1 minus 1, which is equals to 0. This is something which you can say is highly pure sample, where the value is equal to 0, What is the meaning of impure sample? Highly impure sample, where there will be an equal probability. For example, I am saying that gender is female, and what I am saying is, I am saying that a person staying in hostel, how many of them are, yes? Suppose I am saying 2 are yes, and how many of them are no? 2 are no. In that case, you will say to me that the probability will be, 2 by 4 whole square plus 2 by 4 whole square. So what is the probability here? You will say to me it will be 1 minus 1 by 2 square, which will be 1 by 4 plus 1 by 4. So it will be 2 by 4, 1 by 2, it will be 1 by 2. So in a way, can I say that the probability of gender having female value is equal to 1 by 2? So what that indicates is, this is the maximum probability of a Gini index, where the node is highly confused. There are 50% chance to go to yes side, 50% chance to go to no side. And that's why that's the maximum value. So if someone will ask you what is the range of Gini index, it will be nothing but it's from 0.5, I would say 0 to 0.5. 0 to 0.5. 0 to 0.5. So this is the value of the range of a Gini index, right? So I believe this is too much about today's part of the session, where we have majorly talked about that how we can create a decision tree via the help of a Gini index. So here we have seen a very simple example of a decision tree. Afterwards, we have taken one random data set with the help of which we will try to compute the Gini index part. We have done all the computation for the class feature, for the gender feature. We have found out that class is having a minimum Gini value, and that's why we made that as a root node part. And after that, I have said to you that you have to complete the remaining part, where gender is the next particular part that we have. After that, we have talked about what is the training time and the space complexity required to execute this code. And at the very end, we have talked about what is the range of a Gini index. Now, I hope that you will be able to get a clear-cut idea about the Gini index and how we can do the mathematical calculation to calculate that Gini index in a decision tree. With this, let's end today's video. I hope that you find this video insightful. If you do, please share this video to everyone. Hit like button and make sure that you will subscribe to my channel. It would really mean a lot to me. With this, bye-bye everyone. Happy learning to all, and I'll see you all very soon in the upcoming video, where now we will talk about the concept of entropy and how with the help of that concept we'll be able to create a decision tree again. with this, bye bye and happy learning to all. Take care.